So hi class, I'll be going through 13.3 and the summary practice for your revision. So for 13.3, look at question 1. When an electric current passes through a wire of high resistance, the wire becomes very hot and gives out light. Okay, so first things first, it becomes very hot and gives out light. So which of the following statement describes the conversion of energy? So first thing we are going to look at is for electrical energy, right? So look for electrical energy because electric current passes through and it's converted to, it becomes very hot, so it's heat, and then after it gives out light. Okay, so this is quite a simple question. So the answer to this is A. Next of which, an earpiece contains a thin diaphragm attached to a small electromagnet placed near a magnet. When an electric current which is continuously changing in strength passes through the electromagnet, is able to attract and repel the thin diaphragm, which causes it to vibrate and produce sound. So actually this is that your earphone actually is this thin strip which vibrates to the left and to the right, depending on whether it's attracted or repelled. So this creates sound. You don't really need to know the full, you don't really need to know how it works, right? You just need to know that an electrical current passes through, right? And then after it changes the strength of an electromagnet, right? What does the electromagnet do? It's able to attract and repel, which causes it to vibrate and then produce sound energy. So there's an idea of electrical energy, right? And then after that, something idea of which is moving and then converted to. Well, this question is not very good. Okay, this question actually, there's no such thing as magnetic energy. So let's just remove magnetic energy for this. Actually, just ignore this question, okay? This question is wrong. The conversion should be from electrical to kinetic, then finally to sound energy. Okay, if you look through your notes, there should not be magnetic energy. There are magnetic effects. Okay, but in terms of energy conversion, I think this is wrong. Okay, so just ignore this question. So the main switch in the circuit breaker, right? What does it do? It controls electricity to every part of the household. Okay, so when you switch off the main switch in your circuit breaker, like your whole house will have no electricity. Okay, electric cable with damaged insulation is an electrical hazard because the wires will cause an open circuit connecting to the appliance to the mains. Electrical current. Okay, so the answer is A. Okay, because when the damaged insulation, right, let's say if the wire is intact, it doesn't mean that it will spoil or anything. It's just that the insulation protects people from touching the wire, who are touching the wire. So there's no more insulation. When you touch the wire, you touch a circuit where there's current passing through, so the current can then flow through your body as well. This answer is A. So an overloaded power socket is considered an electrical fire hazard. Why? It's because the power socket will draw too much current, right? And then it will generate too much heat, and then it will melt the cable insulation. Okay, a lot of these are facts, so just go and revise. Which is an example of a heating effect of the current? Okay, kitchen caught fire due to a short circuit. Yes. So a kettle with a chrome, we call it a chrome wire, right? When there's a current passing through it, it will heat up. Coil of a hairdryer goes red hot. So answer is D. Overloading occurs when many appliances are connected to the same power outlet, resulting in a large current flowing through the outlet. Which one of the following explains why this happens? Right? This happens because the appliances are connected in parallel. Right? So when you connect in parallel, all of them will draw current from the circuit, and then when you draw too much current, then it leads to too much heat, which just cause electrical fire or something. Okay, so that's for 13.3. So for summary practice, I will speed through the ones that I think are easy. So let's say for this, it is D. Just read it off. Okay, for this, for vary brightness, we're looking for a variable resistor. This is C, which is not a main component of electrical circuit. Okay, so there are 4 components of electrical circuit, right? There is the cell, right? There's the electrical charge, there's the wire. Okay, there's one more component that's not listed here. Do you know what it is? Charge. Then there's the electrical appliance or electrical load. I think go refer to your textbook for the exact definition. I think it's electrical appliance. Let me look at it quickly. It is electrical device, that's what they call it. So the electrical device. So these are the 4 elements to electrical system, at least defined in your textbook. Okay, this is wrong. So which circuit connects to measure the current flowing through a fixed resistor and the potential difference across the same resistor? So let's identify the fixed resistor. Okay, these are the fixed resistor. To connect the current flowing, you need to connect it in series. So this is wrong. Right, the rest of them are, this is correct, this is correct, this is correct. And for the voltmeter, you want to connect it across the resistor. So this is the only one. So that's why it's C. Okay, which is the following is not a parallel circuit? So this is a parallel circuit, quite easy to see. I think this one you also can see that it's parallel. Alright. This one actually, if we redraw it, right, we can just redraw it in this manner, right? You can see that it's similar. This one is not. Okay, this one has one specific path. So this is in series. So D is not a parallel circuit. Which combination of identical resistors gives the largest total resistance, right? So so if you talk about which is hardest to go through, right? B is the one that's hardest to go through. In my class, I talk about using the airport analogy to decide which is the hardest. Let's say if you So let's just compare this and this, right? If I had to go through one long queue and then another long queue, it would take very long. But instead, if I only had to go through one, if I had only go through one queue but I had 2 options available, right? This is in fact lower resistance than this, right? And if this is lower resistance than this, right? We can extrapolate the rest that actually this is the highest resistance. Okay, for question 7, a circuit contains a resistor in series with a battery. So what happens, we need to know the positive and the negative terminal. Okay, conventional current flows from the positive to the negative end. Right, so this means it flows from X to Y for conventional current. Okay, electron flow electrons are negatively charged, so negatively charged will be attracted to positive. Right, so in this case, electron flow is the opposite, is from Y to X, so that's why it is B. So the filament of a lamp is made of tungsten. Okay, so this is a fact, go and remember it. An electromagnet works. When does electromagnet work? So electromagnet works when there is a current passing through. Why does it not work all the time? When there's no current passing through, when it's switched off, it doesn't work, right? And as long as the current is passing through the coils, right, the electromagnet will work. So the following shows a circuit. I think we just did this in the lab, so like if now you understand it, then good, right? But what happens is that if you replace this with a voltmeter, right, the voltmeter has an infinity amount of resistance. So what happens? It becomes an open circuit. If it becomes an open circuit or close to an open circuit, right, what happens? The ammeter reading will be negligible. It will be close to zero. Okay, so which of the following shows the lowest energy consumption? Right, so what happens is that we need to convert everything to the same units. So generally, let's say we want to convert to kilowatt hour. Right, so let's talk about it in kilowatt, talk about it in hours, and we can talk about kilowatts hours. Okay, so this is 0.15, then this is 24 times 5 is 120, this is 1.25, and this is 0.5, this is 0.05, this is 24, this is 1.2, and for 360 seconds is divided 6 minutes. 6 minutes is 0.1. So if I do some quick math, I have no calculator, but I think this will be 0.12. This is like 0.60. 0.625. This will be definitely more divided by 20, so it'll be like 1 point something, I guess. 1 point something, and this will be larger. Okay, so the answer is D. You can do the math and then you figure it out, but important thing is to convert them all to the same units. So doing a table like that would help you. Which of the following is not a way to conserve energy in the household? Okay, so choosing to buy LED lamps. LEDs are more efficient. Switch off power outlets when it's no longer needed. This is a way to conserve electricity. Turn off air conditioner and switch to a fan. Yes. Answer is A. Okay, so you have up to 5 ticks. Okay, so this is very good, and buying 3 is it could be better, right? That's what we're saying. So which is not a useful effect of electricity? So we have coating of medical instruments. This is in the textbook. This is also in the textbook. Sterilization of medical equipment. I don't really like this question as well, but it is it is a facts question, right? So increasing the temperature of the environment, this is a heating effect, right? So this heating effect. This is a chemical effect. And this is a magnetic effect. So this is wrong, so the answer should be D. Okay, which of the following are true of electrical conductors and insulators? Okay, so all electrical conductors have low resistance. This is wrong, okay? There are some electrical conductors that have high resistance, so things like your tungsten light bulb, right? So it has a high resistance so that it can get hot and then emit light. So this is not true. Okay, relative to insulators, they have low resistance, but among conductors, there are also low resistance to high resistance. All electrical insulators have high resistance. Yes, this is very true. This is true. Okay, glass allows electricity to flow. No, glass does not allow electricity to flow because it does not have free electrons. Okay, tungsten allows electricity to flow. Yes, you can see that in the light bulb. So the answer is D. Okay, so here we're talking about, in this table, right, as we went through previously, the symbol for current is I, symbol for voltage is V, symbol for resistance is R, symbol for power is P, and symbol for electrical energy is E. In essence, this is not too important, right? And yeah. You don't need to commit this to memory, but if we use it, we'll give it to you. Okay, but the SI unit you need to remember. Okay, and the SI unit for current, right, is ampere. Then for voltage, it is volt. For resistance, it is ohm. For power, it is watts. And for energy, it is joule. Okay, so let's say you talk about the symbol for this, right? Okay, the symbol for SI unit you also need to know. So symbol for ampere is A, symbol for voltage is V, for volt is V, for resistance is ohm, for watt is a W, for joule is J. Okay, the other one you need to know is that for electrical energy, right, the common unit, especially for calculation, is kilowatt hour. This is the other thing you need to know. So this section I think is important. Commit to memory. This section, good to know, but also not really tested in syllabus, but we have taught it to you, so it might come out, but don't really need to focus on it. Okay, so question 16. So please learn how to draw a circuit diagram. Okay, if in a test you're unable to identify some of the things, let's say you are unable to identify what this is, do raise your hand and ask. Okay, we will provide some sort of clarification. So these things that look like cells are actually not cells, they're actually resistors. What type of resistors? They are fixed resistors. Okay, this is a switch. Whether it's closed or open, I'm not sure. Okay, and also because it's not clear, you can draw either one. This says big battery on it. I'm not sure if your printing comes up clear. Okay, and then you have your N meter and voltmeter. So how I taught you all to approach it is, if you can do it directly, but if not, you also can do it in this manner. You can just kind of draw it on here like that. You have N meter, and connect this, connect this, connect this. You have another resistor here. Here you have your cell. Here you have a switch. And here we are connecting everything together. So let's say if you draw it out in this manner, you can bring it down, and maybe you can neaten it up a little bit. Okay, so let's just redraw this here. So you have your voltmeter, you have your resistor, you have your resistor. Okay, connect it. Okay, then it goes to your ammeter. It goes to resistor 1, goes to resistor 2, it goes to your cell, it goes to your switch, and then that's how you draw this. Okay, so do learn how to draw it. I think drawing is important. Okay, draw a circuit diagram including three of the following: three dry cells connected in series with a variable resistor. Three dry cells, 1, 2, 3, connected in series with a variable resistor. Let's say this is the variable resistor. Okay, 3 light bulbs that are connected in parallel to the 3 dry cells and the variable resistor. Okay, so you want them to be connected in parallel to both of these, right? So what we can do is try to figure out how do we do them in parallel to this. Alright, so let me change this drawing a little bit to make it easier. Okay, so first you have this in series. Okay, then after that we want to connect the 3 light bulbs in parallel. So you have your 1 light bulb in parallel, 2 light bulbs, 3 light bulbs. In case you had drawn it like this, right? The reason you will remove this section, right, is that this section will cause will short circuit the light bulbs. So that's why you erase that section if you happen to draw that and are confused by that. If you aren't confused by that, then we just move on. Okay? So you wanna switch off 2 light bulbs. Okay? So then you wanna draw a switch to switch off 2 light bulbs. An open switch, so it needs to be open. And then the last thing is a voltmeter, measure the potential difference across the variable resistor. Okay, sorry, this is a variable resistor. Okay, so we need a voltmeter. Okay, let me draw my light bulbs nicer as well. Okay, the X needs to extend to the circle. Okay, so we have the dry cells connected in series with the variable resistor, 3 light bulbs. Okay, and then you have your open switch, and then you have your voltmeter. Okay, so this actually is quite hard. If you're struggling with it, I think try to break it down. If you can do like 2 of them, I think that's a good start. Okay, a lot of times I think you can like try to practice like different combinations of them, or maybe like you can just change the values, change the series to parallel, change the parallel to series, and can try as well. Okay, so here shows the various parts of an electric bell when the circuit is closed, when the bell is pressed. So describe how an electromagnet is created. So electromagnet, purely from textbook, right, is that a current flowing through a coil causes the coil to become a temporary electromagnet. In this case, actually, temporary is redundant because all electromagnets are temporary. Okay, so the important part of this, right, is you must mention it is current and it flows through a coil. right? And this will give you your marks for this question, okay? So this is from textbook as well. This is the magnetic effect of electricity. So how will this movement cause the bell to ring as long as the button is pressed down? So first things first, we must say what happens when the bell is pressed down, when the button is pressed down. So right, when button pressed, what happened? Okay, so then closed circuit, turning on electromagnet. What does magnet do? It attracts this, okay? This is magnetic, it attracts this towards it. So it attracts the soft iron armature. You know it attracts because iron is a type of material that can be attracted, okay? So it attracts the soft iron armature, okay? So it attracts the soft iron armature, striking the gong. After that, you must mention what happens after that. This causes an open circuit. Demagnetizing the electromagnet. Right? So then after, you can say the armature will return to the original position, causing a closed circuit. Okay, so now we have established that once when the button is pressed, there's a closed circuit, right? So now we have established that there's a cycle. Okay, so then after you talk about it being a cycle, this cycle repeats as long as button is pressed down. Because when the button is no longer pressed, right, there's no longer a closed circuit, and then the armature won't be attracted to the gong. So you must, so in this case, this question is asking you to explain like why does it keep happening. It's quite reminiscent of, I think, like a primary school like question, I think. So you must try to look at it and try to understand it, like what exactly is happening. And in this case, you're talking about magnetic effect, and then you're talking about an open and closed circuit. Okay, so quite interesting question, quite a fun question. And then after, you must talk about like why does this keep happening? So you must talk about it as a cycle. Okay, so this is how you answer this question. Okay, the power rating for some of the appliances are given below. So calculate in terms of kilowatt hour used by the oven and the hi-fi set. Okay, so whenever you answer a question in physics, right, we always list down what the formula is, right? So the amount of energy equals to be power in watts, in kilowatts, times time in hours, right? So in this case, so the energy for the oven is 10 times 2 equals to 20, right? And the energy of the hi-fi equals to be 125 times 3 equals to 375 kilowatt hour. So the total amount of energy used by the oven and the hi-fi set is 375 plus 20 equals to 395 kilowatt hour. You can leave it in 2 dp or 3 dp, so the answer will either be 395 kilowatt hour or 400 kilowatt hour. Okay, so if the cost is 25 cents per kilowatt hour, how much does it cost to use the oven, the hi-fi, and the lights? So let's call it this total 1, okay? So then this total 2. So what happens if we want to calculate the E total 2, right? So we want to calculate the energy of the lights, right? So in this case, the light actually is 0.06 times 5, which is equal to be 0.30 kilowatt hour. So the E total 2 equals to your E total 1 plus 5, because we have 5 lights and they're each, right? 5 times E light. So it's equal to 395. So we always go back to this value, the one before we have changed it, we have simplified it, right? And we plus 5 times 0.3, right? Which is equal to 396.5. Okay, so if this is the total amount of energy, the cost is equals to tariff times energy, which is equal to 0.25 in terms of dollars, right? And then after we times 396.5, and then here we get the cost. I need a calculator, but you can just work it out. I don't have a calculator on me, so just work out the value and then work it out from here. Okay, so electric bill for okay, I need to work it out actually. Let me use my phone. Okay, I don't know if I have a calculator. Yes, I do. So what do I need? Let me split screen. Okay, so I need 0.25 clear times 396.5. Oh, this is wrong. Okay. I need to convert this to kilowatts. So this is 0.125. Okay, I made a mistake. Let me just go back and do this. No wonder the numbers look weird. So in this case, right, we need to convert everything to kilowatt into kilowatt hours. So it's easy to make mistakes. If you want to change everything to kilowatt hours, one good thing you can do is you can convert it here, so that at least you won't get mixed up down the road. So I got mixed up with it. So actually this will be 0.125 times 3 equals to be 0.375. So the energy total in this case will be 20 plus 0.375, which is equal to 20.4. So you can express the answer in 20 kilowatt hour or 20.4 kilowatt hour. Okay, so let's just change out the portions that are wrong. Okay, so this is 20.4. Okay, 24.4 plus 1.5 is 21.9. Okay, so 21.9 is $5.48. Okay, so
you need to count the number, the cable, USB cable, and the microwave. I think is the inventory really mess up.
So the electrical bill for 1 month, right, is 168. Determine the number of hours it's used daily. So let's say 30 days is 168.90. 1 day equals to be 168.9 divided by 30 equals to be 5.63. Okay, so we want to calculate the number of hours we use the iron. So first we can calculate the cost of the iron. Right, is cost total minus cost. Let's call this cost 1. Okay, because we didn't calculate the cost of iron just now. So 5.63 minus 5.48 equals to be 0.15 cents. All right, so 0.15 cents. So now we have the cost. So once again, cost equals to tariff times energy. So if I calculate the energy, we take the cost divided by the tariff. In this case, it's 0.15 over 0.25. Equals to be 0.6 kilowatt hour. Okay, if we know the electrical iron, so now we were looking for the time equals to be energy over power equals to 0.6 divided by 0.85. We have 0.71 hours. 0.6. Okay. So moving on to question 20. Question 20, this is a lot about graph reading and trying to, you shouldn't need a lot of pre-existing knowledge to do this question. Okay, so you first need to know that potential difference measures the voltage, right? So when it's 2, what we do is we draw a line, and then we draw another line down, and we can say that this is 30 milliampere. Okay, that's how we do it. So next we see when the current is 45 milliampere. 45 milliampere, we calculate it, We draw a line, then we draw a line across, and then we see this is 3.0 volts. Okay, so given the formula is V equals to R equals to V over I, use the graph to determine the resistance of the fixed resistor. So actually, when we want to do this in the proper way, you have to use multiple V's and multiple I's. So what happens is that when you find okay, just forget what I said. Okay, so we have V and we have I. So let's say in this case, let's use this value, right? We use this value. So our V is equals to be 2, our I equals to be 30. So a lot of us use these values and have the wrong answer. And the reason is we don't include the units. So let's say this is V and this is milliampere. First things we need to do is convert the current into milliampere, which is 0.03. So then R equals to be V over I, which is equal to 2 divided by 0.03. This should give us 67 ohms. Okay, 2 or 3 SF, both are fine. Okay. So for the last question, the table below shows the unit cost of energy for an used in an office building for a week. Okay. So what happens is that if you use less energy, it's cheaper. The moment you hit over 100, then it becomes more expensive. You hit over 500, then it becomes way more expensive. Okay, so determine the total energy consumption in a week. Okay, so what happens is that we need to first calculate it for each day and calculate it then for a week. Okay, so first we want to calculate the, okay, so we write down the formula first. So energy equals to be power times time. Right? So in terms of, let's say we want to calculate the fluorescent bulbs, E, right, equals to be 0.06 times 14 times 7. Alright, so 0.06 plus times 14 times 7 equals to be 5.88 equals to be, the next one is 3 kilowatts times 8 times 14, 3 times 8 times 14, oh not 14 times 7. Right, so it's 3 times 8 times 7, it's 168, then I equals to be 0.8 times 9 times 7 equals to be 50.4. So the E, so what happens is that the E total, right, because we still have this element 648, so we need 6 E, actually, okay, plus 4 EII plus 8 III equals to be our answer. So it's 6 times 5.88 plus 4 times 168 plus 8 times 50.4. So let's say 6 times 5.88 equals to 35.25 plus 168 times 4, 672, 50.4 times 8, 403.2, so plus 672 plus 35.28. Equals to be 1110 kilowatt hour. You can simplify to two significant figures. Okay, and this is the answer. Okay, so a few things that can trick you up, right? So first of which is like unit conversion. Then after that, there is actually no, I shouldn't simplify it yet. Let me keep it as this value first. Okay, let me keep it as this value first. So a few things can trick you up. The number of light bulbs, then the number of like days, and then the number of weeks. So it becomes like a math problem in some sense. But the physics aspect to it, right, is just usually, energy is power times time, right? And if you can think about it in that manner, if you understand the concept, then actually you got the gist of the science part down. And I think that's the most important part, if you just know how to calculate the energy and the cost. So now we look about the cost, right? So let's say we break down 1110 into, right? So first we have the first 100, right? So first 100, right, we have it costs 20 cents. Then after that, right, so let's say this is 1110. What happens? We have 1010 left. The next 400 will be at 25 cents. Right, and remaining we have 610. Okay, cost 610. So another way you can do it is you can just look at this range. This is 100, this is 400. So if you take 1110 minus 500, then you have your remainder, and so the 610 is at 35 cents. Okay, so the total cost equals to B tariff times energy. So because there are different amounts of because there are different tariff values, you have to use different amounts of energy times 400 plus 0.35 times 610. Okay, so this is 0.2 times 100 is 20 plus 400 times 0.25 100 plus 0.35 times 610, which is 200 and okay, and the total cost is 333.50. So in this case, you do not round it up and down because it is a dollar value. Okay, so you need to be fairly accurate with this value. Okay, so question 22. So the fan operates at a power rating of 165 watts. If we know that we actually have not taught you any formulas with regards to voltage, so actually every time you see a voltage, you can kind of ignore it for now. Okay, it's switched on for 3 hours, and the cost of electricity, the tariff is $0.25, right? So calculate energy dissipated in 3 hours, right? So energy equals the power times time, right? So if the power is 0.165 kilowatts times time, which is 3 hours, the answer is 0.495 which you can also equate to 0.50 kilowatt hour. If you're wondering whether it's 2 significant figures or 3 significant figures, both are okay. Okay, so if you have it at 0.95 kilowatt hour, that is okay as well. Okay, so cost equals P tariff times energy. In this case, your energy is your 0.25 times 0.495 times 0.25. So your cost actually comes down to 12 cents. Okay, and that's the end for electricity. So hopefully this helps in your preparation for your W3, and all the best. See you around.